Hey there, STEM Chemistry. This is Ms. Ruark. This is Vodcast 5.4, where we're going to learn how to predict the products of a chemical reaction. So a lot of information in this. You might want to make, once we're completely done with this, make some type of a cheat sheet on an index card or something that you can access quickly that will give you all the information in this podcast at an easy access, and it makes sense to you. So here we go. All right, when we predict products of a reaction, first you have to classify. So we've already talked about the types of reactions that there are. And we know that a synthesis reaction is when you combine two or more things, compounds or elements, and you make one product. So there are different types of synthesis reactions. You can have a synthesis reaction with oxygen or sulfur, and that would be where an element combines with oxygen or an element combines with sulfur. Now, the metal that combines with oxygen will produce what we call a metal oxide. And if it's a group 1 metal, it's going to produce a metal oxide with a generic formula of M2O. And the reason for that is because you would have, where'd my pen go? There we go. We would have a metal with a positive 1 charge, and oxygen always has a negative 2. When you cross those down, you end up with M2O. So anytime you see a group 1 metal being combined with oxygen, you know that this is the formula you're going to make. Group 2 metals have MO because group 2 has a positive 2 charge and oxygen has a negative 2. When you cross those down, you get M2O2, but the 2's cancel, so you end up with MO. Well, guess what? If sulfur is combining with metal, it's going to have the similar formula because oxygen and sulfur are in the same group. So, for the same reason, metal oxide in group 1 plus, or metal within group 1 plus sulfur is going to have a formula of M2S. And if it's in a group 2, they're going to cancel, so you'll end up with MS. Sorry. All right. If it's a transition metal, okay, so transition metals are tricky. They're going to produce different oxides and sulfides, and the charge or the oxidation state of the metal depends on what's going on around it. So iron can actually react to produce FeO or Fe2O. So in this one, iron has a positive 2 charge, and in this one, it has a positive 3 charge. Now you might see sometimes a formula that's written as Fe3O4. Okay, I know you're like, what is that? Well, that's something that has a combination of iron 2 and iron 3 in it. Okay, this one here, iron 2 oxide, is very rare, and then iron 3 oxide is going to be more common, and it's something that's found in nature called hematite. If anybody knows anything about rocks and minerals, hematite has some magnetic properties to it. Okay? I might have some. If I have some, I'll bring it in. Let us play with it. Okay, synthesis reactions with oxygen and sulfur. If it's a non-metal, it's going to produce an oxide. We don't call it a non-metal oxide. We just call it an oxide. To differentiate, if it has a metal with it, we call it a metal oxide. So sulfur reacting with oxygen is going to give us sulfur dioxide. Carbon with oxygen gives us carbon monoxide. Of course, you'd balance the equations. And then hydrogen and oxygen gives us water. It's dihydrogen monoxide, but we call it water. Okay. If it's a metal reacting with a halogen, group 1 metals have a positive charge. Halogens, X is the symbol we use for halogen, always has a negative 1 charge, so they cancel. Group 2 metals have a positive 2 charge, and halogens, of course, have a negative 1 charge, so you end up with a generic formula such as these. All right, a synthesis reaction where you have an active metal oxide reacting with water. You're going to form metal hydroxides. So an example of this would be if I have sodium oxide reacting with water. I'm going to have these combine, and you're going to end up with NaOH. Right, now, of course, you'll balance the equation, but this is all about predicting products, and so you can balance the equations and check them with me. I do have them, but I want to keep going and make sure we get through all the information. All right, nonmetal oxides. So an example of a nonmetal oxide would be SO2. If we react that with water, it's going to form an oxy acid. Okay, so it would form H2SO3, sulfurous acid, and then actually sulfurous acid is made in the atmosphere, but it reacts with the oxygen in the atmosphere, which gives us that H2SO4, sulfuric acid, and that would be your acid rain. Oh, yeah. All right. If we have metal oxides, remember a metal oxide is a group 1 or group 2 that's combined with it. So a metal oxide, Na2O, let's go ahead and use that one, and we react it with a nonmetal oxide. Okay? And I said nonmetal oxide just to differentiate. Okay? Na2O plus SO2 is going to give us Na2SO3. Right? It's going to form a salt. A salt is an ionic compound. All right, like I said, a lot of information, but we're going to practice, so don't freak out. Okay, let's move to decomposition. So this is where you have one compound breaking down into 2 or more substances. So if it's a binary compound, NaCl is a great example. It breaks down into its elements. So you would have sodium and chlorine gas. Okay, what if we had sulfur dioxide? Well, it would break down into sulfur and oxygen, right? Okay, if we have a less active metal oxide, so that means the lower part of the swimming pool, it's going to break down into its elements. So what if we have HgO? Well, it would break down into Hg and O2, right? Mercury oxide breaks down into mercury and oxygen. All right, what if we had a metal carbonate? So an example of a metal carbonate would be, let's do CaCO3. Okay, well, it's going to break down into metal oxide, so calcium oxide and carbon dioxide gas. Okay, what if we had Na2CO3? Oops. Well, same thing, metal oxide and carbon dioxide gas. Okay, metal hydroxides are going to break down to produce metal oxides in water. So a metal hydroxide, such as calcium hydroxide, would break down to produce calcium oxide and water. Okay, same thing if it was sodium hydroxide. You'd have sodium oxide and water. A metal chlorate, let's say we have potassium chlorate, is going to break down to produce the metal chloride. Well, here's your metal, potassium chloride, and oxygen gas. This is fun. Okay, I know you guys are like, oh my gosh. All right, and then we have acids that will break down. So let's say that we have H2SO4. Well, H2SO4 is going to break down to produce its non-metal oxides, so SO3 and water. Another one that you really need to know is H2CO3. H2CO3 is, for lack of a better word, unstable. And at room temperature, it's going to break down automatically. It does not like to be in acid form. So it's going to break down automatically to give you water and carbon dioxide. So anytime you have a reaction that's going to produce H2CO3, you automatically, what is going on here? There we go. Okay, you're going to automatically do this right here. Okay, so anytime you produce H2CO3, you're going to automatically break it down into carbon dioxide and water. Don't forget that. Okay, single replacement reaction, where you have one element in a compound and the element replaces another element in the compound. So you have, let's just say we have a metal plus a metal halogen, and then on the other side, metal 1 and metal. Oh, that's going to be bad. Let's not do that. A plus BC. And on the other side, you would have AC plus B, right? So something swapping places. All right, to figure out if the single replacement reaction has happened, you have to check the activity series of metals to determine if the reaction takes place. All right, so I think I have it in here. Not yet. Okay, so I'll have it show up later. Replacement of a metal by another metal, use the activity series. Usually the ones at the top are the most reactive. And then as you go down to the bottom, they are the least reactive. So if it is the two elements, one of them is here and the other one is here, the one on the top is going to be the most reactive. There are examples in this, so I'll show you when we get to one. All right, replacement of hydrogen by water, in water by a metal. An example of this, let's see, most active metals will react vigorously with water to produce metal hydroxides and then hydrogen gas. So where did my example go for this? Sodium plus water okay? And that will produce sodium hydroxide and hydrogen gas. Right? If we have less active metals, the swimming pool ones, they're going to produce steam and a metal oxide. So an example of that would be iron plus water is going to give us Fe3O4. There's that compound I was talking to you about, and hydrogen gas. So here it's got a mixture of iron 2 and iron 3 in it. Yeah, weird, right? Okay, a replacement of halogens by another halogen, you use the periodic table. The higher on the periodic table it is, the more reactive it is. So if I had chlorine gas, oh my gosh, my pen is just not wanting to work with me today. Okay, yes. All right, so if I have chlorine gas, chlorine, this is not funny. Okay, I know I don't want to use this, but I kind of have to right now. All right, so if I have chlorine gas and I'm going to react it with, let's say, potassium bromide. Oh, this is horrible. Okay, so we look at the periodic table. We say that chlorine is higher on the periodic table than bromine is. So it will replace bromine, so we would end up with KCl. Oh, yep, and bromine would be by itself, but because it's by itself, it would be 2. Sprinklehoff. All right, in a double replacement reaction, you have two things swapping places. It has to produce a solid, it has to produce a gas, or it has to produce water for the reaction to occur. You will use your solubility rules to determine if the precipitate is produced. And if it's water that's produced, typically it's going to be a liquid. Okay, an example of that would just be, oh, it doesn't want to work for me. I'll go through that in class with you. Okay. In an acid-base reaction, it has to be a reaction between an acid and a base. Double replacement reaction, this is what happens, and it always produces water and a salt, so HCl plus NaOH. Okay, why is it a double replacement? Because two things are swapping partners, and it produces water and a salt, and this is why we would name it a acid base instead of just saying a double replacement. If we said double replacement, it's kind of generic. We have to be more specific. All right, combustion reaction, we talked about this. Oxygen is always going to be a reactant. Typically it forms water, and if it's hydrocarbons, it's going to form carbon dioxide and water. So CO2 or CH4 plus O2 gives us CO2 plus H2O. Now, it's not always going to be a hydrocarbon, but most of the time it will, so just be careful of that. Okay, here are some examples real quick. Let's go through them. Okay, so magnesium chloride plus aluminum. This is going to be a single replacement reaction. Aluminum and magnesium are both metals, so we come over here and we look. Magnesium is higher on the list than aluminum, which means that aluminum cannot replace magnesium, so this would be no reaction. Oh, that was easy, right? Okay. All right, aluminum chloride plus calcium. Aluminum and calcium are both metals, so we come over here. Calcium is higher on the list than aluminum, which means that calcium is going to come through and knock them out, say, boom, taking your spot. All right, so over here we would have calcium and chlorine, but it's going to be calcium chloride CaCl2, and aluminum is by itself. And you can balance it, single replacement. All right, Na2CO3 plus HCl. Okay, we do have an acid here, which means that this could be an acid base, but there's two compounds, so we're going to say it is a double replacement, and then we'll be able to tell if it's an acid base afterwards. All right, so Na plus Cl gives us NaCl, and H plus CO3 gives us H2CO3. Red flag. Remember, I told you this thing automatically breaks down into water and, I wonder if my battery's dying. Water and carbon dioxide. Okay, so we've got Na2CO3 plus HCl breaks down to give us NaCl plus H2O plus CO2. Oh yeah, this is an acid-base reaction. Why? Because you have a salt and water formed. Okay, this one's going to be a double replacement reaction. Let's see if you can figure that one out. Okay, this next one's going to be a decomposition. My pen is dying on me. Okay, it's going to be a decomposition reaction. This is going to decomposition. They're going to both break down to produce a metal oxide and carbon dioxide. This one's going to produce a metal oxide and carbon dioxide, and I'm going to run out of time here. And then these are going to be both synthesis. All right. So go ahead and figure this. Oh, and combustion. Ha! All right, guys, I will see you in class.